So in the ceiling, the existing standard now is R20. Well, you know, a standard 6-inch fiberglass pad is an R19, and then we get our surface air film and our sheetrock and whatnot, so we're up to the R20. So basically, we've been meeting the requirements of 6 inches in the ceiling. We're proposing south of the 8,000 degree day line to go to an R33, and north of the 8,000 degree day line to go to an R38. So basically, north of the 8,000 degree day line, which is the Huron area, we're saying that the new requirement is now 12 inches of insulation in the ceiling instead of the old standard 6 inches. And in the southern part of the state, 10 inches. This is probably the controversial one, and that's the wall. And the old standard was an R of 12.5. And so we used the 3.5-inch mineral wool or fiberglass insulation, which was an R11. And then again, we had our sheetrock and our still airspace on both sides of the wall, and our exterior Silbrite or Celotex fiberboard type sheathing. So we got up to the R12.5 very easily. Now we're saying we're going to require an R19 no matter where we're at, north or south of the 8,000 degree line. And I'll show you something in that in just a minute. Then we're raising the requirements for floor insulation almost doubling. Foundation wall, and it's our judgment in South Dakota that we probably won't be insulating floors. It would be smarter to insulate foundation walls. And I'll show you what we have in mind in a minute. And then there's, we don't have much slab construction, but there's a revised standard for slab. One big thing, inflation. In the southern part of the state, we will accept double glazing. The northern part of the state, we're going to ask for triple glazing. And let's see. This is just labeled how do we propose to meet the new standards. And like I said, the ceilings will be going to 10 or 12 inches for a loose fill, or we can use, say, 2 R19 bags in the northern part of the state. Walls, and there's several options, I guess, but one, we can go with conventional 2x4 construction, in other words, what we have here now, with the 1/2-inch fiberboard sheathing, and fill the stud cavity with a U.S. foam type insulation. This is a urea formaldehyde, is the name of it, and it's got quite a high insulating value. An R of about 5 to 5.5 per inch, as compared to, say, fiberglass with an R of about 3.5 to 3.7. So if we did that, we would get our wall value up to about an R23. Another option is to go with conventional 2x4 construction. Use 1-inch polystyrene sheathing. And I know there's at least one house in town now using that. And then use an R11 or R13 bag. You'll get up around R21 value. Remember the requirement is an R20. And a third option, which we don't see much of in this country, but they're doing an awful lot of it in Mississippi and Arkansas, is go with the 2x6 stud wall, and this is room for 6 inches of insulation on the R19 mat. And our total wall will be up around R22. And again, windows double the surface glazing. Floors, and this is the big thing, I guess, too, is I said we would like not to have to insulate the basement floors, but in lieu of that, we'd like to insulate we'd like not to insulate the first floor, but to insulate the basement wall. And we're thinking now to an approximate R11, and this is not firmed up, it's just a proposed standard, and it's Of course, there's a number of ways to do that. Again, you could go with full, if you have masonry construction, we could go with full 2x4 per inch sorry, that's bad. We could go with a couple inches of extruded polystyrene or urethane type, the rigid board type insulation. We could go with 3 inches of this bead board material that you see on the market quite a bit. It has a lower R value than the extruded polystyrene. We could go with lightweight concrete blocks with the core filled with vermiculite plus, plus 1 inch of extruded polystyrene. Or we could go with the wood foundation, and then we can do, we can put whatever we want in there, a 3-inch batt or a 6-inch batt. Excuse me, I have one more chart here. And when we talked about energy savings in the past, we always said, you know, we talked about how much insulation, and we always said, well, you know, what's a good investment? What's the optimum amount? And I hear a lot of talk today that we're not concerned anymore with saving money. What we're concerned with is saving energy, and that may be true, but by and large, the bottom line is that it has to be cost effective, or the public is not going to buy it. And we predicted some potential energy savings. We assumed a very modest 1,000 square foot home, and we predicted the approximate heat loss reduction in the northern part of the state as being about 35%, and in the southern part of the state about 28%. And we followed that down through, and we said, well, with that kind of a heat loss reduction, what are our approximate annual fuel savings? And I'll just pick one off the chart here. I said if oil costs 40 cents a gallon, in the southern part of the state we would save about $70 annually by doing these things. In the northern part of the state we would save about $95 annually. And following that one step further, I said how much additional first cost will this annual savings amortize? In other words, how much more money can I spend now in construction to realize this savings? And in the southern part of the state, then on that basis, again, using oil at 40 cents, I say about $760 I can spend right now. I can afford to spend that much right now to realize that kind of a savings. In the northern part of the state, it's going to be something in excess of $1,050. That's oil at 40 cents a gallon, which is probably about today's price. Not the price 5 years from now or 10 years from now, which could make it look a whole lot better. I am on natural gas in my own home. Doing all these things, my annual fuel savings, if I predicted this right, and it's kind of hard to predict heat loss because you can't predict people's living habits. But my annual savings is quite small, about $45. In terms of how much $45 would amortize, we're probably talking closer to $300 to $500. But then you can do a lot for that amount of money. We're talking about electric baseboard, and I just worked it out for 3 cents, 4 cents, 5 cents. But you can see the annual savings is very substantial. We're talking $200 to $300, and that's going to amortize a bunch of money. And I would very well suspect that we would not only be able to build in those energy-saving features that we want to require, but we'd also have some spending money left over for buying groceries.
We have time for a couple of questions from the audience, if you have a question for any one of my panel members. maybe they've done a good job of explaining it. There's a question right here.
Things would be better for walls that verticalize. I can't remember the correct word, the foam or the gas.
You're talking about in a house that's already built,
Well,
or
one that's already built or one new built.
Okay, I sort of listed them here in the order of the highest R value. So for insulating value, you want to pick one up on top. Unfortunately, that's probably also the highest cost.
I can't read that far.
Okay, the polyurethane or the, what was the?
Urea formaldehyde.
Urea formaldehyde will be somewhere around 5 to possibly 6 R value. Okay,
that's per inch, isn't it?
that is per inch, yeah. The polystyrene in the 4 to 5 range, the fiberglass down around 3 to 4, 3.5 to 4. Okay, the cellulose 3.7, which would be something you'd blow in. As far as the costs on these, I don't have any real good figures, except to say that generally the ones with the highest R will probably cost more also. So really, you're going to have to look at the type of construction you have in order to do an economic analysis to see which one you would be better off using. You have to do the sort of thing that Jim was showing you here on the cost analysis. So it's kind of hard to say just on a blanket statement. You almost have to look at your house, and this means really about several hours worth of calculations to come up with that answer.
Is there any other question? Merle.
Alan, I have a question for John again. I was interested in the changing requirements of the house and wall turning yard back to 20. And I was wondering that most of the other houses of the old one are left. And do you have any comparisons on the savings in energy between the house you took with the old standards versus one with the new standards? Do you have any percentage savings in those figures?
Well, what I call the existing standards have been, probably 2-3 years, have been around, well, say 5 years. And what I came up with to go to the new standards, say in the Huron area, that we were talking between 28 to 35%. Now, I think if you're talking about a house older than 5 years ago, that basically you could do the same thing, because you can always, well, hopefully we don't have too many houses around anymore that don't have insulation in the walls. Insulating the attic is very easy. There's some things we can do. I think one thing, that has bothered me for a long time is we don't insulate our basement. And I have, no matter how I cut it, I always come up with about 30% of our total heat loss is out of our basement. And I think you can make a substantial reduction there. And really what happens is sort of a subtle thing, You not only reduce the heat loss, but even if you don't live in your basement, the floor feels warmer. And that sort of, transmits to your brain, and you leave that thermostat alone. Just like if you super insulate, if you want to use that word, the walls and the ceiling, what really happens is at 72 at that thermostat, and maybe where I'm sitting over against the wall, it's 62. So I've set up a convection current in there, and I feel drafty, and my wife is slaving over the hot stove, and she's belly aching because I'm turning up the thermostat. But I'm sitting over in front of the 65 square foot of glass. And I didn't take time to show it here because we're running out of time, but there's if you're interested in this, there's a energy house called the Arkansas Storry. And they've taken this, they've gone several steps beyond what we're proposing to do here. Reduction of glass is one of them. But like our requirements, we've always said that that the glass area in the house needs to be 10% of the floor area. So I've got a 240 square foot living room in my house. So to meet the minimums, I need 24 square feet of glass. Well, just like everybody up and down the street, I've got 65 square feet. And that's the big killer, that glass and that infiltration. So they've gone to reduction in glass area. They've gone to overhangs that shade the windows. They've gone to, well, quite frankly, it's been there on the walls, they've gone to 2x6 stud walls. They haven't gone with the 2x4s and the insulated sheathing or anything like that, because it was their goal to build that house for the same dollars that they're building the old house, and yet save you 50% of your heating costs. And they're very proud that they can guarantee you a 50% heat loss reduction.
Thank you. Okay, we're going to go to the next part of our program. Now, we are consuming some time here. On the other hand, it's a very important subject, and I hope that it's interesting to you. The next person on our program is Dr. J.O. Storry from South Dakota State University, and he's the Dean of Engineering over there. And he's going to tell us for just a couple of minutes about the project that's planned for near Huron here by East River Electric. We started with 15 minutes, was it? We cut it down to 2. He's scared now. I don't know if he'll come up with it. In 30 seconds, he's going to. But Dean Storry is going to tell us about a very exciting project that's planned for near Huron, where they're going to do some experimentation with the generation of electricity with giant windmills. And it's East River Electric Power Cooperative, I think, that's going to do that. So, you know, we've got a couple very exciting kinds of things going on in South Dakota in solar energy. And a lot of it's going on there at State University. They're putting solar energy in at Mount Rushmore. The School of Mines, their competitors are doing that at the other end of the state. But we're very fortunate to have some of these really futuristic things happening right here in South Dakota. So, Dean Storry.
Thank you, Alan. Good evening, ladies and gentlemen. For literally thousands of years, wind power has been used to propel ships. And from the early days of South Dakota settlement, we've seen windmills pumping water. And for a while, there was some wind generation of electricity. Now, wind generation of electricity made some sense in the early days when our electrical loads were low, when we really didn't expect very much out of an electrical system, and we didn't get much either. But when we wanted lots of power, we found that the battery system and the wind charger just really didn't do the job. And one of the things that annoys me more and more is the fact that we have no simple, good energy storage systems. And this means that if we want to wash clothes when the wind is not blowing, and we're depending on the wind for power, we must have stored this energy somehow. And we don't have a good, simple, cheap way of doing that. So wind generation went by the wayside. But people who live in South Dakota are quite aware and sometimes proud of the fact that the wind blows a lot out here. And people have been wondering, perhaps we can do something about utilizing wind energy for not supplying a major part of our electrical needs, but even if we can supply some, we might be worth doing. Now, if you ask me if the wind projects planned are going to be economically sound, the answer is a very resounding no. Why is it being proposed? It's being proposed to get information, to learn things. HRDA requested proposals on wind power sites. There were some 60 plus proposed. Of these, 17 were selected for monitoring. The proposal that was submitted by East River with some assistance from South Dakota State University was one of the 17 that is being monitored. If any of you wish to see the monitoring station, you go east to the Beetle Electric Co-op office on Highway 14, turn north 3 miles and go east about half a mile, and in the pasture on the bluff over the James River you'll see a tower 160 feet high. At the 30-foot level and at the 150-foot level there are indicators of both direction and wind speed, and these are continuously recorded on a moving paper chart, and these then are analyzed. Awards have been made for 2 machines, 200 kilowatts apiece. These towers will be 100 feet high. The generator will be driven by a 2-blade propeller whose diameter is 125 feet. If we are successful, we will be in line for a 1,500 kilowatt generator. It will be on top of a tower 150 feet high. The 2-blade propeller will be a fiberglass propeller 200 feet in diameter. And so it's a formidable engineering problem to design and build this thing. It would operate in parallel with the existing power systems, and you might say if it relieves any water flow in one of the dams on the Missouri while we're storing energy in that fashion. Jeff Nelson of East River is the project manager on this, and he's been in contact with Aberest and our congressional delegation, and they are, incidentally, I understand, very much impressed by the support that the people of South Dakota and many of our cities have given the project. I'll tell you, if we get a 1,500 kilowatt machine, you'll be able to see it from Highway 14 every day, and not just part of the time like you can see the tower now. Thank you.
That was 37 seconds. That's not bad. Is there, we could take one question from Dean Storry, if there's any questions.
Anybody want to ask one question?
Why do you say economically it's not realistic? Costing too much?
Well, the cost of the 200 kilowatt machine, as I recall, is estimated to be in the order of $1 million. The cost of the 1,500 kilowatt machine will be about $4.5 million, which is about $3,000 per kilowatt. A big steam station today will cost, what, $600 to $900 per kilowatt, or $1,000. You can't make too dogmatic about that, because you'll always be wrong and you'll always be low. But is that right, Bert? We are always low on these estimates, and but the cost is very high per kilowatt installed, and then worse than that. The wind does not always blow, so you get full capacity output from the plant like you could from a existing plant. So the previous large machine was one built on Grandpa's Knob in Vermont during the days of World War II, and a lot less was known about materials in those days. I believe the propeller was steel, and one of the things that happened was that one of the propellers broke off and sailed down the mountainside, and they never decided to try doing it again. But we know more about materials, we know more about fiberglass, and we have a lot more hope today.
There's one half of the question.
There's several unusual designs in the are they making progress rather than take 3 times later?
Well, you've all seen the pictures of the Dutch windmill. You remember the windmills pumping water. You've all seen 2-blade airplane propellers. That's what would be most like the windmills now planned. There are some other strange-looking windmills. One that resembles half of an egg beater, and it won't even get started by itself, but once it gets started, it does pretty well. And it would spin around on a vertical shaft, like a vertical egg beater. And several models are being investigated in various places. The URDA models at the present date happen to be the two-blade airplane type propeller. There may be something else will shake out as being much better than those propellers, but that's where we're hoping to be successful.
On an individual level, work being done as far as individual homes.
Well, there are a few manufacturers of smaller units. One of the problems, again, if you do not tie to the utility system, is what do you do about storing the energy? You want to go to a huge battery system. Wind Charger in Sioux City, which used to build sets, the last correspondence I had, their biggest machine was a 200-watt machine. And I just stood in dumb amazement at 200 watts. Do you know how much 200 watts is? That's what my reading lamp has got. And that's just like nothing today. Maybe we've gotten into a lot of bad habits, but that's where we are. You can buy sets of 2.5 kilowatts, and I guess a whole lot of sizes on up. And but unless you want to try to parallel with a utility, you've got energy storage problems. And if you're willing to fuss with the batteries, you can still have a battery system and be completely independent of them. Now, if you have a battery system, then you've gotten yourself one whole new set of problems, and that almost all appliances are designed for alternating current. A motor on a washing machine just simply will not run on DC. If you want to try it, well, just plan to buy a new motor because you'll simply burn this one up. And even things like thermostats might not work on DC because on AC you can have switches separate slowly. Things will go very well. On DC you better get those things separated and separated fast or you will burn up the switch. So DC is not without problems. Now, maybe the day will come when whenever you go outside, you'll see a line of windmills. I don't know. We've got to learn a lot before this will happen.
We put up with all those television towers, so.
It took 20 more seconds, didn't it?
Well, that's all right. Did a good job. Appreciate it very much. Okay, we're going to dismiss this panel and just tell you that these people are available to you. Call George Peterson here at Northwestern Public Service. You can call Brian Heisel at the State Energy Office. If you've got questions about school here, you can call Lloyd Turnwall there. And Jim Valeer is available to you down at the State Farmers Home Office. And you can contact John Feldeman at State University there in Brookings. If you have more questions, and they'll be around here for a little while. The next thing we're going to do, we're going to talk about solar energy for a little while. I'm not going to scare you by the number of people we're going to bring up here, but we've got several people. We've got Dr. Eno, Bert Eno, he's professor of mechanical engineering at State University. And he's really in charge of their solar energy program there at State University in Brookings. And we're very fortunate to have him. You want to come up here, Bert? And we've got Roger Price here from Huron. He has a house right here in town, in Idaho Southeast, where he's relying on solar energy to supply part of the heat for that house. Want to come up here, Roger? We've got Kurt Johnson, who's from Huron. who's going to build a solar house. He's in the planning stages now. He hasn't bought the solar unit or anything yet, but he's planning. You want to come up here, Kurt? And I believe that's everybody. And before we get started, if you want to just stand up and stretch a little bit, it might make you feel better. Be more excited about
You gonna have me lead off or somebody else?
wherever you go.
Flip this on. Conservation and alternate sources, and I think that we've had the problem of conservation addressed, and I'm all for that. I'm a great proponent of conservation. I think that's where the first effort ought to be put. But we also should be looking at alternate sources, and we are investigating quite thoroughly a number of them. Dean Storry spoke of one, and of course solar energy is another. Now there's quite an appeal to that. It's very abundant, obviously. It's a clean source. It's not going to pollute. And it seems to be just generally aesthetically appealing. As far as the uses of solar is concerned, many possibilities exist. All the way from space heating to processes, industrial processes that need heat for one reason or another. About 25% of all the energy that's consumed in this country goes into space heating, and this makes it a pretty good candidate for solar heating because it isn't that difficult a technology. The technology is fairly well understood. It's a matter of refinement. It's a matter of gearing up the industry and getting responsible products to the consumer. Generally, at this point, there is available some products, and people to install, take care of solar heating and domestic hot water heating using solar collectors. This can be done on commercial buildings, industrial buildings, and residences. And I'm going to address most of my discussion to residences because I imagine most of you here are more concerned about the place you live in, and only the boss is concerned more or less with the commercial establishments or the industrial establishments. There's basically two kinds of heating systems as far as collection and transfer of the energy is concerned to storage or space heating or domestic hot water heating. And one is a liquid type system, commonly called a hydronic system, and the other is the air heating system. And I may speak briefly about both. I've got at first here a few slides just showing an overview of some cases, what they look like, what the collectors on a roof may look like.
And then I've got a couple of schematics showing the modes of operation for the hydronic and air heating type systems. And then I want to address myself a little bit to the question of what kind of considerations must be made. What kind of things must you concern yourself about before getting into a solar system? And finally, probably the last question, the most important, is the question of economics. Well, first slide shows a domestic hot water heating system in northern Australia. This one also shows a domestic hot water heating system in southern Australia, where the collectors are stood at a higher or steeper angle because of the fact that the sun is not as high in the sky to the southern latitudes. Here's one of the first really good experimental projects in this country, the MIT house built in the early 60s for space heating, and it was a hydronic heating system. The collectors on the roof, steeply pitched roof, as you can see. Here's the Dover house that still exists, and it was built as an experimental house several years ago. And here I see the collectors are an integral part of the roof and rather attractive, as a matter of fact. Here's one of 3 houses that have recently been built near Fort Collins, Colorado, to run 3 different experiments. And one is a hydronic system, another is an air system, and I think the third has an evacuated tube type absorber. It's a new concept that we in fact have at Brookings and are investigating ourselves. I won't say too much about that tonight because of the time limitation. Here's a house that was built in 1958 by George Lerf from Colorado, and it's an air heating system. He's got 2 banks of collectors up on the roof. He's got storage, air handling, and so on. And this has been in continuous operation, providing about 35% of his energy needs for both space heating and domestic hot water heating since 1958, with no more than a couple of fan belts having to be replaced. And it is the prototype to a modern system that is presently on the market, which seems to be somewhat the leader in the air heating systems. And perhaps I'll say a little more about that later. Here's a close-up of his collectors. And as I say, this is an early prototype, but you can see that the air heating system requires larger ducting, and the collectors are a little bit more cumbersome than a water heating system. I'll say more about that in a moment. Here's where he stores his heat, in pebbles, in rocks that are in these large cylinders. They're 2.5 feet in diameter, about 18 feet high, 2 of them inside the entryway of his home. And the hot air passes down in one direction, depositing the heat for later use. When he needs that heat to heat the space at a later time, the air passes in the opposite direction and pulls the heat off. Those bins are full of pebbles. Here's the schematics that I was talking about. The best way to explain the modes of operation that are involved in solar heating is by these schematics. You would have a couple of pumps here, a couple more over here, that would operate a fluid through these cycles. When the sun is striking the collector and there's energy to be collected, stored for later use, you better get on the other side. Then a pump would operate and drive a fluid through this cycle here, probably an antifreeze mixture, going through this heat exchanger. At the same time, water, maybe stored in a 1,000-gallon tank here, would be driven through this cycle, pulling the heat off the heat exchanger and depositing in the storage tank. Now, when there is a domestic hot water demand or a space heating demand, then pumps would operate these circuits and pull hot water out and drive it through the domestic system or through the baseboard convectors in the home circuit. If this is depleted, not up to temperature to provide useful heat, then an auxiliary would take over and make up the difference either for space heating or for domestic hot water. In contrast to the hot water or hydronic system would be the air system. In this case, you'd use a similar collector. It's going to pass air instead of water, perhaps. A little different channeling involved in that case. You'd use a rock bin for storage instead of water, actually. And the best way to explain it is to say if there's a demand from the house, thermostat calls for heat, and there is sun available from the collector at this time, these dampers would automatically orient in the usual system so that you pass the heat all the way down and up through the collector and back into the space to be heated. If there's no demand from the house, but there is heat available at the collector, then you want to store that heat for later use. So these dampers would reorient and a blower would drive air through this circuit here, leaving the heat in the later. If now the sun is not out, it's nighttime or a very cloudy day, but you do have a demand in the house, and you do have sufficient temperature in the rocks, then these blowers will orient in such a way that the blower will drive the air up through the rock bed back into the house. Finally, if there's no energy available from the solar system, either at the collector or in the pedals, then you may bypass the solar system entirely and just go to an auxiliary, which makes up the difference. Okay, now there's many considerations to be made when thinking about a solar system, and I've listed several here, and they're not all inclusive. The local climate is very important. What's going to work well down in the southern part of the country is not necessarily going to work well in this part of the country. As a matter of fact, it's got to be bigger up here than it does down there to provide the same percentage of total demand. Building design is very important. If you're starting out building a new building, then you can fit it accordingly. You can design the building to accommodate a solar system. If it's a retrofit, the problems may be very difficult to handle. You certainly have to orient the building in such a way that the collector can be located and tilted to the south for optimum heating purposes. You need to worry about what kind of a thermal storage. That goes hand in hand with whether you're talking about a hydronic system versus the air system. And I already spoke about the choice of coolant in that respect. I'm going to skip on down toward the bottom. The backup system. You never strive to do 100% of the heating job with a solar system. You just can't count on the sun being there. As a matter of fact, if you were to design a system big enough to handle 100% or even 90% of the space heating needs of your house, then throughout most of the year, that would be substantially oversized, and you would have made far too much of an investment. So there's some kind of an optimum, and ordinarily somewhere around 60 to 70% of the space heating needs might be met with a solar heating system. That would require, of course, a full-size conventional backup, electric heating, oil, gas, whatever. And finally, the question of economics. I think Jim made the point here a while ago that it always gets down to the bottom line. What's the pocketbook say? Can you afford it or can't you? And, well, there are many products that have come out on the market recently. There is literally over 100 manufacturers at this point that are putting products on the market. Some of them have had years of research put into them and have evolved as very responsible products backed up by considerable testing and performance evaluation. And this can be shown to you in black and white by the responsible companies. On the other hand, there's the charlatans that are trying to get a product on the market without sufficient time for performance evaluation, and in some cases not even desiring to do so, maybe making a fast buck and getting out. And so in this infant situation, or as the industry is in its infancy, I must apply a few words of caution. Be very, very careful. Somebody asked me before the session here tonight, well, how do you get information? How do you know? Well, I must admit it's difficult, and there aren't too many experts around, and time will tell. There is information available, but it's in a scattered kind of a manner. There is one book that I would suggest that if you're interested in this business, you can start with. That's Buying Solar, put out by the Federal Energy Administration and available for $1.85 from the U.S. Printing Office. You can come up and look at this later. It gives you a basic introduction to what solar energy is all about. It doesn't compare systems. Now, here's another one. The Solar Energy Industries Association has been formed and has taken on membership from various manufacturers and consultants and so on. And they have now a booklet here that's called an index, which contains many manufacturers' abstracts of his products, indicating what his products are intended to do. Now this index, and the people that put it out take no blame or credit for the content of what's in here. They're not in any position to evaluate the claims that are being made in here. But they have asked one thing. They have asked these manufacturers, can you provide standard performance test data? And if they answer honestly, some say yes and some say no. Now that standard performance test data refers to the National Bureau of Standards interim test requirements, and a company can volunteer to have those tests run on his collector or his system, and therefore after considerable testing of that sort, say whether he does or does not, in fact, have performance data available. Now, he's not obligated to do so. There are no requirements at this point. There is no legislation forcing this kind of evaluation on any product on the market. And as I say, in the meantime, until this happens, until we can push for this kind of legislation, there are charlatans around that are going to sell you much less than what you should receive. I started touching upon the question of economics, but what I just said has a lot to do with it. There are poor products on the market. There are products that are while claims way beyond the possibilities are being made for some of these products. You first have to evaluate and realize whether you're getting a good product or not, and a product that in fact will produce what is claimed to be produced. Then comes the question of how many dollars do you have to spend and is it worth it or not. And roughly speaking, at this point, I can, how do you handle the question of economics? If you're playing purely the game of economics, you're not trying to be a philanthropist and just worry about saving energy for everybody, but just playing the game of economics, then you have to compare what you invest, amortized over a number of years to write off the investment, to what you save by not using that conventional energy. Now that brings it all back to what's your conventional energy costing you. Well, I don't know what it is costing right here in Huron, but if let's say it was 4 cents per kilowatt hour at the present time, then I did a little doodling in which I have found that you may, at an 8% simple interest and a payoff of 15 years, assuming that that energy cost stays at 4 cents per kilowatt hour, you can afford to pay $13 per square foot of system installed. Now, in other words, why do we do it in terms of square foot? Because you need so many square feet to get the sun in the first place. All the rest of the system just has to follow along and be matched to that. And if you bring it all back to how much are you paying per square foot, you could, as I say, in 15 years, manage to pay off a system that would cost you as much as $13 per square foot. Now, we know that energy isn't going to stay at 4 cents per kilowatt hour. Projections are it's going to be far greater than that. It may be double that on the average in the next 15 years. And if we add Carter's incentives for investment in solar to that, we may bring ourselves all the way up to the possibility of being able to invest $30 per square foot and get it back and have the unit free and clear in 15 years. A couple of rules of thumb is that not only that is how much you can afford to pay for a solar system, but I want to say one other thing. People seem to have the concept, some people I should say at least, that the sun can do wondrous things, that it doesn't take very much to accomplish a great deal of heating. But in reality, the sun is very, very dispersed, and you need a lot of square footage to collect that sun. Now, even assuming that you've got a good collector and total system which has a high efficiency of conversion, you still need a lot of collector to just receive that sun before the conversion and transfer to useful purposes. Let me give you just a rough rule of thumb. Let's take a house that meets the present standards that Jim spoke of at the present time. That is something like an R12 in the walls, an R20 or 22 in the ceiling, and double glazing on the windows, and so on. And let's say that house is about 1,600 square feet of living floor space. That's what you want to heat. It's going to take you at least 400 square feet of collector to accomplish 2/3 of the heating of that space. And don't let anybody tell you any different. I'll end it there, but I'm very happy to answer questions afterwards.
I have questions for Doc. I think we're talking about being fortunate of having things in South Dakota, and we're very fortunate to have Doc Bert Eno over at State University there, because the man who obviously believes very strongly in solar energy. It's the kind of people you got to have if you're going to bring it about, and we're going to have it very shortly. So I'm glad you're around, Doc. Next, Roger Price, I think in February, wasn't it, Roger? Added a solar unit to his house, big white square house over on Idaho. And if you just take just a little bit of time and just tell us your experience with that and what, maybe give us some figures if you got them on what you saved.
I don't have
Okay, well just comment
it. But I just
on
wanted
your
to,
experience.
yeah, I'll just kind of basically, he went through most of the principles of stuff. The pebble system or the hot air system, the sun collects the heat, and if your rocks are hot enough, well then I don't know how to explain that. You got two air ducts into the house is what you've got. When the sun collects the heat, like he explained on his chart there, if you're calling for heat in the house, it'll automatically, the fan will blow it right straight into the house and from the solar collector. And if you're not calling for heat, it stores it up in the rocks. And then at night or something, when it does call for heat, well then if those rocks are hot enough, it'll blow it into the house. And if the rocks are cold and there's no heat, well then your conventional system kicks on. And that's like he said too, that's the big thing. You gotta remember that right now especially that this is just a supplemental heat. And you can't, like I said, unless you really get a big area like mine is only 100 square feet. And the most I could expect was probably, I would suppose, 25%. And I'm not sure my house is insulated that good either, but basically we started this as kind of an experiment to see, because I'm worried about the cost of energy and conservation and stuff, and I figured over a period of years, it's going to probably pretty well pay for itself. But like he said, it all depends on a lot of things. Like they said on the other panel before, you got to have the right insulation, the right ventilation, and all this stuff goes hand in hand. And if you get part of one and part of the other, why you mess up your system and you're not near as efficient as you can be or you could be. And I think that's the whole idea of it. You got to get efficient in everything, or try and conserve as much as you can, or whatever here now. I don't know exactly. Like I said, I'm the non-professional up here. Don't know too much about it. I would.
Have you got any figures? Now you put that in February, have you?
Yeah, I run it, let's see, probably about 3 months. And I've got some of them. Well, I know I haven't rechecked it, and I know the electricity costs have gone up so much from last year. I mean, I've got the figures between this year and last year, but I don't know the percentage of the rate, so I really can't. I know my gas bill is a lot less. I can say that. But how much or the percentage of the comparison, I have no idea.
And you haven't had it a full winter yet. So
No, right. And so I really can't say one way or the other. Like in the next year at this time, we'll have a lot of figures and pretty well know. But and I did put more insulation. I think I've got 12 or 14 inches insulation in the attic now where I didn't have before, and that's going to make a difference. And there's a lot of things. See, I'm starting out new in this, and just like you said, there's no experts. Nobody knows really quite what's going on, and you got to kind of take it a step at a time and plan ahead a little bit and just kind of work at it that way. That's about all I can say. But like you said too, you can't just rush into it. And like I said, I've only got 100 square feet of collection space, and I know for a fact my house is way too big because it's a big 2-story house. But the idea was just to test it as far as I was concerned, see how it would work, and I figured the price of energy is going to get higher. There's no question about that. And if we can, I'd be happy if it paid for itself in 15, 20 years, I mean, that would be no problem. But I would, I'm sure people probably got a lot of questions on different stuff, but I don't know, you want to let him say
maybe have some questions.
Maybe say that and have questions later, because I could say a lot of things, but I don't know what people want to know.
Yeah.
And if they ask me, then I'd be all right. But, so I think that's
Can anyone dispute this now? Yours is the first solar house in Huron, isn't it?
In here it is, yeah.
It'd be one of the first in South Dakota, so if you want to compare this, you can't compare it to the first television, you might be able to compare it in significance to the first television set here. You couldn't compare it to the first color TV. But this is my opinion. Someone here's disagreed with me. But I think that solar energy, pretty soon, like in a year, you're going to see a lot of that. There are 15 solar homes in Rapid City now, and there are a lot more planned there.
It's coming more all the time,
You bet.
for sure.
And you can just bet with me now if you want, like a dime or something like that. In a couple of years, you're going to see an awful lot of solar energy used in homes. I'd just be willing to predict that right now. And we haven't seen the utility rates go up like they're going to have to go up in the future. They really are. It's going to make the costs that we talk about here are really going to be meaningless as we go along. So when you talk about really expensive and really scarce energy, $3,000 or $5,000 for a solar unit, it seems like really expensive today. In not very long time, it isn't going to seem very expensive. I bet you on that. Okay, Kurt Johnson will talk just a little bit about what his experience is. He's going to build a house, and here he is caught in the energy crunch, and he wants to do everything that he possibly can to protect himself in the future, because he probably lived in this house for 30 years or so, or maybe longer, or maybe less that time, but probably quite a long time, and he wants to protect himself against the future. Kurt?
Well, my wife and I are building a new home. And of course, our home is being built so that it's designed, hopefully, that it could accept solar energy. And we're putting in the insulation R factor of at least 20 in the walls and orienting the windows to the proper direction and so on. One of the big problems that I've found in trying to even find the proper type of solar heating system was to find hard information rather than advertisements. And I've called throughout the country to try to and ask them to send me information. And I've got some that says, you know, save up to 90% of your heating bill, which is utterly ridiculous in South Dakota. Maybe they could do that in Arizona, but it's impossible here. And finally, I am getting some information now. When you really work for it, it gives you some facts that you can figure out what your house is going to be losing as far as heat loss, and that you can make some calculations and try to attempt to see what the proper system would cost. And it's more than $3,000 or $4,000. At least for the size of house that I'm building, it'll probably be, I would think that if you could do it for $7,000, you'd be pretty lucky to get it. $7,000? $7,000. I think it'll probably be $7,000 or $8,000. And it takes, and I'm beginning to get some facts now, because when 3 or 4 different companies start saying the same thing, then it becomes more believable, and they tell me that you're going to have at least 400 square feet of collector space, and that probably would more than that in order to achieve a 50%, somewhere around that figure, efficiency reduction in fuel bill and so on. But it'll be a good experiment, because a friend of mine is building a house that's super insulated, and both of ours will be using propane gas, and so we should be able to tell if this system really saves that much, or about the same size square footage wise and so on. So it's interesting to do, but it's going to be costly, and it's hard to get good information. And you don't even know who to talk to, because nobody seems to know it. Well, Dr. Eno does, but I've never had an opportunity to talk to him overnight.
Sure. Now we'll open the questions. You know, you mentioned this idea of insulating the house and doing all that. It's extremely important. School Mines is about completed. I think the end of this month they'll have the heating and cooling, solar heating and cooling installed there at Mount Rushmore. Well, they're never going to be able, the way the building is now, to supply more than 50% of the heating and cooling with solar energy. And the reason is because the building is very poorly designed in terms of energy conservation. For one thing, you've got a whole wall of glass. You've got to have it so people can look at the 5 faces up there now. And I don't know if they had to add in more glass for the 5th face or not, I'm not sure, but It's not even thermal pane glass. You can imagine that. And so now they're going to come to Senator Aberest and the Congress and ask for an appropriation to, insulate that building and get rid of that single pane glass and make some improvements there. And they might be able to get over 50% efficiency there. But that's where they're at right now. So that's a very serious problem. So I want to open it to questions. Anything you have for any of these three people?
Well, I have a question. I think we were talking about futuristic ideas.
Mm-hmm.
I think a lot of us are looking for some kind of a scientific breakthrough. Maybe during the space age test, some kind of exotic breakthrough will come along. After all, if you're heating rocks and taking the heat off of that, I guess the cavemen probably did that quite a while ago. They had rocks out in front of their cave and the sun shone on it. At night they took them inside and kept them warm. So we're just doing that in a sophisticated way, and I have great admiration for the guys who are working that system. But it seems to me with all the know-how that we've got, somehow we ought to have a breakthrough that would do more than the old way. And that's, well, that's the engineer question.
Do you want to respond?
Yeah.
No matter how hard we look and how hard we try, we can't find anything much cheaper than rocks. And they do a pretty effective job. They don't have the heat capacity that water does. But when compared with anything else, you could collect the heat, give up the heat to air passing through. There's nothing that beats them. Now, there is some consideration of eutectic salts at this point. There is even a company that will sell you a system that contains eutectic salt. I still have my reservations about that. I was approached the other day about it. And I'm going to personally carry out an investigation to the point where I'm going to be completely satisfied that it's good or it's not good. But at this point, water heating system ought to use water, air heating system ought to use rocks. Actually, the technology that's involved in space heating, solar space heating, has been well understood for 3 or 4 decades. There's no big surprises, and I don't look for any great technological breakthroughs. The one thing that has been mentioned up here sufficiently now, I think, is that you need lots of square feet to collect the sun. I've talked to so many people that seem to have the feeling that if we just get the right engineer to work on this problem, it's just like making mini computers and finally microcomputers. Eventually we'll have 10 square feet that can collect all the sun that's necessary to provide the space heating. It just isn't so, because we can't change the nature of the sun and its dispersed manner in which it comes to us. But I don't happen to feel that there are major technological breakthroughs coming. I think it's a matter of refinement, mass production, and getting the cost to a point where it's reasonable. And the best, and probably the quickest way that's going to happen is not so much that solar products are going to come down in price. Inflation will take care of that and keep them at least where they are. But the cost of energy is going to be high. I might mention that there's only, at the present time, 6 total heating systems, solar heating systems, 5 of them water, 1 air heating, that have been approved by ERDA for federal funding in federal demonstration programs. It's not very many out of over 100 manufacturers at the present time. But that points up the danger and the difficulty in finding the proper information. But I would respond and say that South Dakota State University has been there for a long time. Give us a call.
We aren't charging for this advertising. Good thing. So, well, here, we have a question right here first.
Well, it's a big question. There are some Jackson centers currently out there
Very minute.
Yeah.
There's South Dakota, the state of South Dakota provides you a reduction of $2,000 from your total assessment on your property if you install a solar system. But with South Dakota, the way they operate this assessment matter, you first have to call up the assessor, and he comes out and he jacks up your assessment because he hasn't been there in the last 10 years. Then he'll take $2,000 off. So that's not a big incentive.
And even if that didn't happen, that $2,000 wouldn't amount to very much. I mean,
No,
it's
it's
not
just
$2,000
tax
on
on
the
that.
tax bill. It's just off the assessment, so it wouldn't be very much. Now, the federal government will have some incentives. The Carter Energy package is before the Congress now, and it's before several different committees. Talk about putting something in jeopardy, dividing up several committees of Congress is what they'd be putting something in jeopardy. But hopefully in about a month they will have something. I think it's pretty safe to predict that they will take action in that area to give you some kind of a tax credit. They're going to give a tax credit for insulation and other types of energy conserving practices, and they are going to do that. It's in all the bills that have been proposed, and it's going to be hard for them to avoid it. They're talking about making it retroactive to April 20th. And I was hoping by the time we had this meeting tonight that we'd be able to provide some of that information, but we can't because they haven't done it. And we'll try to keep you posted on that as we go along. But there. Well, they would. The reason that, right, that's a scary thing. It's a scary thing. But the bills in both the House and Senate that were introduced, the major ones that have the momentum going, do talk about April 20th, and that is the date. That's the date that Carter gave the package to the Congress. And I think that, well, you can't guarantee that, but if Congress operates as it has in the past, they will come up with that April 20th date. I think it's a pretty safe date, but it hasn't happened yet either. But the congressional watchers would tell you that April 20th is a pretty safe date. Well, I forget what number the bills vary, but they're talking about direct tax credit. For that. Right. No, I'm not positive. Right. Right. But you see, what I think will happen in Congress is that would be a politically popular thing to do back home, so they're asked to do that. No, I mean, there's a good chance. Right. Right.
This is a supplemental comment on tax credits. For the very reason the document said, we ran a survey of all the directors of equalization. We asked if anyone to take advantage of it in the 2 or 3 years we've been on the book. It sounds strange, we found out no one can. Because of that, I think it's probably sitting on the books. South Dakota says they have a tax credit for solar energy. I think it's going to have to be improved a great deal. And this, during the next couple legislative sessions, I believe that we'll bring some legislation to improve that, to bring it up to a level that one would be acceptable. If we're talking about $7,000 or $8,000 units, there's 2 avenues there. Not only the property tax, but the sales tax on a $7,000 or $8,000 unit would be quite substantial. It might be able to do something in that area. More than that, we've seen comments from you folks in Washington here in regards to what we should do. We've already had some suggestions from people working in this particular area, et cetera, as to what they feel would be necessary to strengthen that. To the thought of
Okay. Yeah.
You haven't said anything about fireplaces as far as heating is concerned, and fireplaces seem to be really the thing nowadays. Instead of somebody, young people who are going to jail want a fireplace before they want a television or a stereo. And
Stereos would be better.
the reason I mentioned this is last winter we went out to Bozeman, Montana to visit my sister and her husband who had just moved there from Fort City, Iowa. And they had just completed a new home. And this home had a solar furnace, which was not operating. But they had a heating and ventilating fireplace. And this heated their entire house of 2,500 square feet. And I thought, at first I told my husband, I don't know if we want to go there because I know we're going to freeze. Their furnace was hooked up. And we were comfortable all the time. I mean, really comfortable. wonderful in this area, and especially in the very wooded areas. All they had to do was take their pickup and go a couple miles into the mountains and get firewood, and they didn't mind putting a log on the fire.
Kind of fun to do.
It's kind of fun, right? And they would put a log on the fireplace at night, and it would keep it until the next morning. They would just put another log on. And I don't know how soon they'll have their solar burners hooked up, how long it will be before they do, but
Systems would work well together.
Worked very well. Of course, their winter was extremely mild.
We'll get someone to comment on fireplaces. You know, the reason we have the Franklin stove is because the traditional fireplace is a negative factor in the house. I mean, you lose heat with it. Even though you use it, you lose heat.
This is
But you're talking about a special kind of fireplace they've got.
Into their ductwork, and it's a heating and cooling system.
Is anyone here familiar with some of the new types of fireplaces that are on the market? Oh,
They're manufacturing companies.
I know one thing out in Oregon, they break them all shut and put a heater in front of them.
Yeah. Right, the old style.
Pictures of that.
Sure, the old style fireplace.
Yeah, because you can't get the heat out of it.
Yeah. Oh, that's right. That's a good point. They've got a number of attachments or additions that you can put in now that make them. There's one that's sort of a C-shaped thing that you actually put the wood in the fireplace, and there's a little blower, and it helps blow the hot out air into the room. There's another one that has water circulating around the fireplace, and it heats the water and adds it if you have a hot water heating system in your house. Adds to it that way. Another modification that they feel is mandatory is to get the air for the fireplace not out of the room, which we do in a traditional fireplace, but to get it from an air duct, special air duct that you build so it gets air from outside to keep the fire going. That takes less draft, it doesn't take the air out of the room. You're not losing heat. I believe so. Yes.
I don't want to say a little something about fireplace, but one thing you have to remember is that very many people jump in the fireplace, it's very soon going to see wood stove. But this is not much of this part of the country. And there's a right and a wrong way to play a fireplace, too. If you aren't put properly, they actually use the heat out of the house. And instead of putting in a big fancy fireplace and all this water poured up and all this, I think we better look at how long if there's wood in the country, very many people wood.
There are some arguments you can make for wood, in the sense it is a renewable resource. You can make more wood. Can't make more coal or petroleum. And we have never grown trees with the idea of using them for wood. I mean, we use them for aesthetics and so on. And there are other countries in the world, China, for example, they harvest the trees. They grow them very thickly in their parking areas and so on, and boulevards down the street, and they harvest them for fuel. And we've never had to do that. Never looked at that, but it is a possibility that we can look at. I mean, in the future, if we want to go that route, it seems feasible. Also, in the Black Hills area, they need to do a lot of thinning of the national forest because of the bark beetle and so on. It's been neglected seriously over the years. And the reason is that we don't have forest fires like we used to have, so nature doesn't thin the forest anymore. And so there's a supply there. What's that? Yeah, we a lot of trimming to do. The shelter belts that were put up during the 30s and so on need to be thinned. And we also are losing the elm trees, which are something. But I think your point is still good, that if everybody got into burning wood, it would be hard to keep up with that. But if we did decide to use wood as a source of fuel, we could do some things to make more of it available. Any other, Sheldon?
Usually the collector. Usually the collector is the highest expense item involved in the thing.
You were talking about $15 square foot. For the entire
Total system, and then relegated back to, yeah.
square foot of collection.
Yeah, total system installed back to the collector, related back to the collector.
Yes.
I would like to comment on the subject of collector, we have a lot of collectors. Several years ago, especially at the University of Wisconsin, where we were we made national. We came up with a figure that he said the national average solar energy that fell out on the earth was 28 BTU per square foot per hour. Has there any testing made to repeat that?
28,
28 BTU
and that's
per
average.
foot per hour, annual average.
That's averaged over night and day and everything else, then, all the hours in a year. No, I can't refute that. That's probably Duffy or Beckman.
In that case, it's not only just at the house, it's only getting about 2,800 BTU per hour.
That would be close.
Just to stir you up a little bit, I think we should bring this to close, but just to stir you up a little bit, the belief that I have is that some of our giant companies have become bureaucracies and don't respond to the needs of the country quite as well as they should. I'd be willing to kind of predict or just kind of bet you a little bit that the Japanese will jump on this solar energy thing. If we're not careful, the cheap solar collectors he says they already are.
The Hitachi collector for domestic hot water heating has been used in Japan for quite some number of years. They have installed something like 500,000 of them around the world. Japan and Australia, which don't have gas and oil reserves.
And there are a lot more.
Pardon me.
Yeah.
A number of years ago, we were impressed in Israel with all the water heaters on top
Right.
of the tanks, on top
Right.
of the roof.
Yeah.
Heating the
A lot of early work in the solar field is done in Israel.
Yeah, you're absolutely right. Absolutely right. Because they were put in an energy crunch situation, so they put their scientists to work on it. They made it a national goal, and they accomplished it. And that's what we did in the space program. We got threatened by Sputnik, and we made it a national goal to do it. And we did it in this country, but we haven't been able to do that yet in energy. Is there another?
Has anybody done any figures on that house up here they put up a year ago about what it costs to bring it on the solar energy on that and what it costs?
You know anything about that, don't you?
I've heard claims, and I would count it as claims. There is no evidence that I know of that backs up the claims I earlier heard. I do know that it's about 175 square feet of collector, and I wouldn't say that it's even, very, very substantial collector like double glazing and all that sort of thing, or selective surface or anything like that. So I would estimate that approximately 25% of the heating requirements could be met there.
That house is just a mile east of Pier on Highway 14 on the right-hand side of the road. And the collectors really don't distract from the hooks of the house.
Right. The difficulty with many, many of these cases is that there is no instrumentation by which they can honestly tell you what's coming out.
Well, that's from one year to the other, you know what I mean? Some makes it, I just saw some makes it or something.
Is there one more question before we wrap it up? My hand's tight or not.
How much space does it take for an animal to provide solar water?
In our part of the country, domestic hot water, well, it depends on how many members of the family and again their habits and so on, but let's say 4 members in a family. Domestic hot water probably is going to consume 16 or 17% of the energy, 15% perhaps, of the total energy consumed in the house. And so you can just scale on down from, say, if you're trying to provide 60% of the space heating with 400 square feet of collector, well, then it takes just 1/4 of that to accomplish your domestic hot water heating. This, I hate to give rules of thumb like this, but I'm always pressed into the position where I have to. At this stage of the game, stick the money into talking to an engineer if he wants to charge you. It's worth it. It's going to be several years before things are down to the point where you can just buy the product and be certain of it. And in the meantime, you don't want to wait because you're going to lose. But the investment now has got to be backed up by careful consideration and the advice of a professional. It really does. This book right here will tell you that 6 times through. That's probably why I like it.
What's your phone number over there?
Let's see, what's yours? I'll give it to you.
Yeah, you're going to get
5717. I get enough phone calls.
Yeah.
I try to respond as much as possible, but it does get a little out of hand sometimes too.
But it's something that probably the state will be looking at, is providing more. You've got the extension service coming out of Brookings and so on.
I think we'll attempt to do more in the extension area. The state engineering extension, I think, will be gearing themselves more for this sort of thing in the future.
Sure.
But if somebody's got really embarking on a project and want to do it now, I'll try to help.
That's good.
One more question with regard to the statement you made about the 5 water and 1 air heating systems that the government approved for demonstration projects.
Right.
How can a private individual get in touch with the people that make decisions as to whether or not a specific project could be used as a demonstration project? Who makes that selection? Where these demonstration projects are put in?
Well, IRTA is sponsoring certain commercial installations or demonstrations around the country, and HUD is sponsoring certain residential demonstrations. And HUD has sponsored products which I think, frankly, have been poor in some cases. I don't think they've had a good evaluation process. IRTA has been much more careful about it. As a private individual, there's no chance that you could get a demonstration project. As a builder, you could perhaps get one by applying to either HUD or IRTA. And you can get I've got it somewhere if you want to check me later, a toll-free number that can be called to get this kind of information out of IRTA.
That's in that brochure we got.
It's in several places that I know
that
of.
one myself. But,
IRTA has set up an information center. You call in and ask your questions and they'll try to help you.
yeah, it's in that yellow brochure.
Where to find information. I don't think they're in too much of a technical position, however, on that phone.
Aren't they building a church in Aberdeen that's one of those demonstration projects?
Yeah, that's going to be sponsored by IRTA, and it's going to be a Solaron incorporated system that's put into that place by Solar Dynamics out of Minneapolis.
Good. So the church in Aberdeen, it'll be using the center. Okay, we're going to draw it to a close. I want to thank you all for coming. Appreciate it very much. And these people will be available for a couple minutes if you have any questions for them afterwards. Thank you.
We have a plan in our